Hello friends, today we are going to talk about the two important protocols that are associated with network layer, ARP and RARP, that is address resolution protocol and reverse address resolution protocol. So these protocols are we know that whenever we are using the IP address, that IP address we call it as a logical address, and most of the time in a network the host or the routers are recognized by their own logical addresses. That means they are known by their own IP addresses. So logical addresses are of internet type of addresses, and these are called logically because most of the times, majority times, it is implemented in software. Hence the logical address used in TCP/IP is a IP address and 32-bit long, and there is one more address that is available apart from this logical address, that is called as a physical address. So this physical address is nothing but the address of your hardware. It is the address of your hardware. So it is represented by 48-bit MAC address. So it is generally called as a MAC address. So this MAC address is a 48-bit MAC address. Out of that, first 24 bits represents the company or the organization who has manufactured that particular hardware, and the next is the unique ID of that particular device. Next 24 bit is the unique ID of that particular device. So we need to convert these physical addresses into logical or logical addresses into physical. So for that purpose we need to map these addresses, and the solution for mapping is a static mapping and a dynamic mapping, so that we can deliver the packet appropriately. So static mapping, here you create a table that associates the logic address with a physical address. That means in one column you will have a logical address, that is your IP address, and in one column you will have a physical address, that is your device address or a hardware address. So you have to map it manually, so that is called as a static mapping. However, the physical address may change. Now let us consider that your IP address is fixed and your hardware address is also fixed, but in most of the cases, if your that particular machine that contains that network card or a device, it goes down or it gets shifted to other device or it gets shifted to other network, then in that case there will be a problem. So you need to manually configure that table in front of that logical address. So manually you need to configure the physical network, that table, so that you can again update that table. So that is what the problem. If the physical address get changed, so the complexity gets increased. Whereas in dynamic mapping, you need not have that table where the mapping has been done of logical address to physical or physical to logical address. So in dynamic you use the protocol called as ARP and RARP. So ARP stands for address resolution protocol. So it maps the logical addresses into physical addresses, and RARP is a reverse address resolution protocol. It maps in a reverse way, that is physical address into logical address. So here exactly this ARP and RARP are there in network layer, and it comes along with a IP address. So we know that IPv4 have a certain advantages as well as disadvantages. So most of the time your devices are identified by its IP address or by its domain name. So domain name, then you need to convert it into IP address, and that IP address you need to find out the exact physical address of that one. So for that purpose, this ARP will come to your rescue. That will be providing you the proper solution to find out exactly what is the hardware address of your device. So what ARP means, let us try to understand it. So address resolution protocol, it is an application that uses the logical address to identify the destination host. So IP packet are encapsulated in the frames, and these frames are delivered across the links. So the link may be source to source, the link may be source to router, it may be router to router or router to destination. So these 4 cases are possible. That means source to source, directly machine to machine, source to router, router to router, and router to destination. So and you need to find out the physical address or MAC address of the device to whom you will be sending the frames. So mapping of these IP addresses into physical addresses is done through this protocol. Now how exactly this ARP works, just try to identify it, just try to understand it. To find the physical address of any host or router on its network, send first ARP request. So first you need to find out the physical address of the any host. First you need to send the ARP request. Okay, this is what my IP address, I know your IP address, but I don't know your hardware address or physical address, please let me know. So that request has to be sent. So request message, what it consists? The request message consists the physical address of the sender, the IP address of the sender, that means both the addresses of the sender, the physical address of the receiver which is not known, so all zeros are put over there, and IP address of the receiver is known, so you put the IP address. Then ARP request message is broadcasted by a physical layer on the net, and Ethernet will broadcast it with all ones as a destination address, and it is received by each and every station on the physical network. Then the intended recipient will send back the ARP request. Now the broadcasted message has been received by each and every receiver, and the recipient for whom that IP address is meant or for IP address is there, that recipient will receive that one, and that recipient only reply to the sender. Now it is not broadcasted. Initially request is broadcasted, but reply is from that receiver and sender only. It is not broadcasted. It is from receiver to sender. That's why it is called as a unicast. So it will check it. It will change its packet by all ones will be replaced by its physical address, and this physical address is sent to the sender, and then the communication starts. So this is what the example of this one. So here you can see that system A wants to communicate with system B, so it will send a ARP request. So this is what the IP address of this machine, IP address of B. So it will send a request. So request is received by all the stations in the network. So ARP request is a broadcast. Now what will happen? Since this IP belongs to device B, so the B will understand it, and B will replace that address of the receiver by this physical address and simply reply it to A. Now you can see that here arrows are there for each and every machine. Here there is an arrow from B to A only. That's why it is called as a unicast. So ARP reply is unicast. Okay, so this is how exactly your ARP operation works. Okay, now ARP packet. So whenever you are sending, you need to encapsulate all the information so that all the requests and replies need to be understood. Now you first try to understand how exactly the ARP packet looks like. So it will give you the information of first 16 bits of hardware byte, then it will give you the information of protocol type, hardware length, protocol length, and the operation. Now operation in case of ARP, operation type 1 is for a request and 2 is for reply. Then you will have a sender hardware address, that means 48-bit information you will be sending. Then you will be sending the 4-byte IP address. So 6-byte IP address, 6-byte MAC address you will be sending as a hardware address, and 4-byte IP address you will be sending as a sender's IP address. Now your target address, hardware address, you need to find out, because here you are expecting your data, so that needs to be filled initially with 0, because you don't know what is the physical address of your device. So all values are put as a 0. Your target IP address is known to you, so that IP address you need to put it over here. So in following example, we will try to understand how exactly it works. Okay, now just try to understand what are the fields and what is its significance. So H type, it is a hardware type, it is a 16-bit defining underlying the network, whether it is a Ethernet or other type of networks. For Ethernet, it is a type 1, and ARP can be used on any physical network. That means what kind of topology, whether it is a bus, whether it is a ring topology, then whatever may be the physical network is there this ARP will work. And for Ethernet, the H type is hardware type is of 1. Then P type, protocol type, then what kind of protocol you are using, whether you will be using IPv4 or any other version you are using, then in that case you need to identify it. So that will represent IPv4. So IPv4 has a standard value that are defined by the protocols. So it is 800.16. Then ARP can be used with a higher level protocols. We know that it is also able to communicate with the TCP. So IP and TCP, they are work together. So ARP is able to communicate with the higher level protocol just like a TCP. Then header length, it will tell you the header length of your physical address bytes. Then protocol length, it will tell you about the logical address that are used. So for IPv4 the value is 4. Then operation, it is a 16-bit defined by the packet. If 1 number is there, it is a ARP request. If 2 number is there, it is ARP reply. Then you will be sender hardware address, sender protocol address. Protocol address is nothing but a logical address, that is IP address of sender. Then target hardware address, initially it is filled with a 0, and target protocol address, okay, that IP address you will be sending through this ARP packet. Now how this ARP packet is sent? So it is put it into a frame. So we know that this is a frame. So preamble SFD is there, destination address is there, source address is there, type you will be putting here. Then this ARP request packet or reply packet is put into data format. So data is not there, now you are requesting, so you need to find it out. So first you are putting this ARP request as a data, and after that CRC. So this frame is sent over the net, and the type of this packet is 0x0806. So this is how the ARP packet is encapsulated in the frame, data link frame, and it is sent over the network. Now the operation, how exactly it works. So sender knows the target IP address, as we have already seen, known the IP address of the to whom will be supposed to send the data. So IP asks the ARP to create the ARP request message. Now you know the IP address only, you don't know the physical address of that device. Then in that case you should know the physical address of that device. So ARP request is generated. This will give you the information of sender's physical address and IP address, and it will initially filled with 0 and target IP address. Now the message is passed through the data link layer and it is encapsulated to form a data frame. Then every host on the router receives the frame. Since the destination is a broadcast, as we have said that ARP request is a broadcast type of message, so it will simply broadcast and it is received by all the destinations, all the receivers on the net, and all the machines except the targeted one drop that ARP packet or that frame, and to whom that packet is intended, only that machine will receive that ARP request, and target will reply to ARP message that contains its physical address, and it will simply reply to the sender. It will not broadcast to all. It will simply send to the sender. So sender will come to know, okay, this is the hardware address, this is the IP address. Now they will start communicating. So the sender receives the reply message and knows the target's physical address. And there are 4 types of cases, as we discussed in previous slides, that the source to source, source to link, source to router, router to router, and router to destination. So these are the 4 cases. That means both the hosts are in a same network. Both the hosts are in a same network. So simply IP datagram will be sent to the destination and the request will be sent and the information will be carried out. Now the next one is, the case 2 is the host is sending the data to the router. The host is sending the data to the router. Then in that case it will send a request, and it will send a request to router, and router will send its hardware address to host, and the frame is transmitted. So this is the second case. The third case is from router to router. So now the router will generate the request, ARP request, to the next router, and the next router will reply its hardware address to the sender router, and the communication will take place. And the final case is where the router will send the packet to the host, that is the destination. So here again the request will be sent back and the destination's address will be recovered. So this address will be sent again, that will be communicated previous back, and this is how your whole communication will take place. So the router receives the packet to be sent to the host on the same network. So this is how exactly the 4 cases you can easily classify in case of ARP. So in short we can say that ARP request is a broadcast, whereas ARP reply is unicast. Now we can see the example how exactly you are sending the data. Now this is a hardware type. Okay, so this is 01 means it is a Ethernet. This is the protocol type. 8000 means it is a IP v4 you will be using. Then this is the type, hardware type. This is your protocol type. Now this is the operation. 1 means you are sending a request. You are sending the request. Now here it is an IP address of device A. Here it is an IP address of device A. Let us name it as a device A and let us name it as a device B. Okay, and this is a MAC address or physical address of your device A. Okay, so similarly here it is an IP address. Okay, and this is a MAC address. Okay, now this address which is in a pink color is not known to A. So what A will send? A will send its own address. A will send its own address. So here it is the sender's physical address. Here it is a sender's IP address which is converted into hex. So 130.23.44.43.20 is converted into hex, and that hex is represented over here. Now this is the hardware address which is put into 0000 because this address is not known, and its address, target address of this one. Now this is, we'll consider that it is on the same network. Now this is not known to it, so not known to it, that's why it is get converted into. Now it is put into this information, and here it is, you can see that the address is put as a 0000. Okay, destination address is put as a 1111. So this 11111 represents that it is a broadcast message. It is a broadcast message. Okay. Now who is sending? The sender's address is written over here, so that address is written over here. So MAC address of that is not known, that's why it is broadcasted, and here it is written in ARP request, it is 000. Okay. Now next, when the request is received, what will happen? Now the address which was initially put, now ARP request, now this is a reply. So reply is from the receiver. So now this will become a sender's address. So the address will be replaced by this physical address, its IP address. Then it will take the address from that request and it will put its hardware address over here and its IP address over here. Now that will be reply, put it into data, that is encapsulated into data, and the same information is now copied here. So you can see that this information is copied and this information is copied as a destination and source address. So source address information is put over here and destination source address is put over here. So this is how exactly the reply is from receiver to sender. Okay, so this is how the ARP works. So now the next is the RARP. RARP is the exactly opposite to ARP. The only thing is that here you know the physical address, you don't know the IP address. You request for the IP address and you will get that IP address from the receiver or from the server. So let us consider that you are booting your machine from simply ROM. It does not consist any hard disk. Okay, it does not consist any hard disk. So you will be booting your machine from a simple diskless machine, and you are booting your machine with the help of simple ROM or a disk, floppy disk type of disk used to boot it from that devices. So it cannot include any IP address because it is booted from the machine. It is booted with the help of ROM. That's why it does not consist any IP address. So IP address is a logical address. Now you need to map your hardware address to logical address. Now you will request to the server, Baba, this is what my physical address is. Now tell me what is the logical address if I want to get connected to the net. What should be my logical address? So this request is sent back to RARP. This protocol is called as a RARP, where you will be asking for the logical address using physical address. So this is called as a RARP protocol. So here you know the physical address, you send a request, again it is a broadcast, and you will get the IP address of your machine accordingly, and you'll get your IP address accordingly. So your RARP request is a broadcast and RARP reply is unicast. It is same as ARP. Now the packet is also same as ARP. The only difference in RARP and ARP packet is in operation field. In operation field, now you can see that change here. Previously in ARP it was request is 1 and reply is 2. Now it is changed, the request is 3 and reply is 4. That's all. This is the only change in RARP packet. This is the only change in RARP packet. So this is how you can resolve the address complexity that appears at the network layer. So if you know the logical address, you can get the physical address using ARP, and if you know the physical address, you can get your IP address using RARP. So this ARP and RARP will help hand in hand with IP to resolve the address problem. Okay, so this is how, again it is same as, now the type is only different for RARP. It was initially 8060 for ARP, now it is 8035 for RARP. This is the only difference, and encapsulation is again same as the previous one. So this is how ARP and RARP works. So thank you.